Alright friends, welcome back. In this video I'd like to go ahead and take a second day for section P.4 in your prerequisites chapter of your textbook. In the first day of P.4 we went ahead and took a look at basic factoring of polynomials. We took a look at examples that had a greatest common factor, or GCF, and we also took a look at some examples where we were trying to notice the structure of some binomials. Seeing if they match up to a difference of squares, a sum of cubes, or a difference of cubes. Okay? So in this video, I want to go ahead and take it a little bit of a step further. We're going to take a look at some polynomial examples that are 3 terms and also 4-term polynomials in this video as well. Okay? So let's just go ahead and get started with that. One of the things that I'd like to have you, sit next to you here as we do problems is this factoring checklist that I gave you guys a copy of, which if I could find it here, here it is right here. Okay, so again, anytime you factor any sort of polynomial, this is the checklist you're going to go through, right? You're going to start at number 1 where it says always, 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 no matter what, no matter the example, look for that GCF, if there is one, okay? There may not be one in the problem to speak of, but if there is one, we are going to go ahead and talk about factoring it out. If there's not one, we're just going to go ahead and move on in this list to other things to try, okay? And we're going to kind of do that depending on the number of terms that we have. So if we have a 2-term, we're going to go ahead and talk about applying one of these formulas here from the last video. But today we're going to go ahead and move on to 3 and 4 terms. And so if we focus on 3 terms here really quick, it turns out that there are 2 things to check for. Maybe your 3-term polynomial, your trinomial, is a perfect square trinomial. Or maybe it's just simply a trinomial that's just got a couple of binomial factors, okay? And so if it is a perfect square trinomial, what that means is that it is going to be a formula problem for you, okay? Where, very similar to the last video, we're going to be matching up what we have in our example to one of these forms. And a couple of key characteristics about these forms is that they both start off with u squared, they both end up with v squared, and really the only difference between these 2 forms that you need to pay attention to is the fact that this operation is a plus in this form and this operation is a minus in that form. Other than that, these are identical. And that plus or minus are going to come into play because whenever you go ahead and write what they're equal to, it's either going to be u plus v quantity squared or u minus v quantity squared. Okay? So we got a lot of practice noticing our forms in the last video. We're going to do the same thing in this video. But let's just say real quick that it does not match up to one of these forms. In that case, you're going to have to do this process of unfoiling. And there's actually 2 different methods for that. I'm going to show you one of the methods in this video, and then I'm going to actually include another little supplementary video that shows you another method that involves a little bit more algebra and a little bit more steps that I think some people learned last year as opposed to the method that I'll be doing in this video. So I just want to go ahead and dive into that by taking a look at a couple of examples here. And so let's just go ahead and dive in here. I'm going to go ahead and skip around. There are a ton of examples in this set of notes, so I actually want to go ahead and start off here with number 19, and then we'll kind of jump around, okay? So here in number 19, we have a polynomial, and if we go down our checklist, remember, the first thing you always want to check for is always that greatest common factor, the GCF, okay? So we're going to look at all 3 terms of our polynomial, and it does not look like I'm going to have a GCF here because the leading coefficient of this polynomial is a 1, and numbers like 1 and -4 and +4 don't really have any common factors, all 3 of them together. So we're going to move down in our list. We have 3 terms in this polynomial, so that means that this is either going to be a perfect square trinomial or it's going to be a trinomial with some binomial factors. So let's first check to see if it's a trinomial that is a perfect square, right? If it is, then remember the characteristic thing about those formulas was that this operation right here was either a plus or a minus. And here it looks like that's going to be a minus for us. So if this is going to be a perfect square trinomial, we need to try to see if we can match this up to that form of u squared minus u times v. Actually, I believe it was 2u times v. There we go. Plus v squared. Okay? Because if it does fit this form, then one of the things we're going to be able to do is just apply the formula for it. We're just going to automatically be able to say that this is u minus v squared, and then we're just going to be done with the problem at that point. Okay, so that's the trouble, is we need to figure out if this is going to match up to our form or not. And in order to answer that question, we might just go ahead and look at u squared and v squared individually. Okay, so let's first identify u squared, right? If we go ahead and take a look here, it looks like playing the rule of u, that's pretty straightforward in order to find. Playing the rule of u is simply just going to be x for us here in this example. If we go ahead and take a look at what's playing the role of v squared, well, that looks like there's a 4 sitting in its seat. And so, again, setting up one of those maybe mini equations from the last video that we talked about, playing the role of v in this equation, I believe, is going to be a 2. Okay? Now, the only thing left to check here is the following, right? This middle term. Is it the case that if I do 2 times u times v, with u and v being what we defined over here, is it the case that I end up here with a negative 4x? Well, that's something that you could try. It's something that you could do mentally if you like, but I'll write it out for the purpose of this example. So I want to test 2uv. Well, playing the role of u was x, and playing the role of v was 2. So is it the case that if I do negative 2 times x times 2, I get negative 4x? Well, yeah, absolutely, yes, it is. Okay, so that means that this is a perfect match for that perfect square trinomial formula, and we could just go ahead and apply it straight up here. So I'm just going to go ahead and do that. I'm following the formula. This is just going to be the quantity u minus v all squared. Well, playing the role of u, we already said was x. Playing the role of v, we already said was 2. And so our final result here is just simply going to be the binomial x minus 2 squared. And that's going to be our result for that problem. Okay? So pretty simply done. Again, it's a very similar process to what we did in the last video, wherever we were trying to match up to the difference of 2 squares or 2 cubes or whatever. It's, again, just looking at a formula, seeing if it applies, and then applying it if it does. Okay? So again, I'm going to go ahead and skip around here maybe to another example. Let's maybe go ahead and take a look at number 23 here. Okay? Lots of examples to choose from, so we're going to skip around. So, taking a look here, again, first thing you always want to look for is a GCF, all right? So, greatest common factor. If you look at numbers like 9 and 24 and 16, that group of 3 numbers together, I don't believe we're going to be able to take out a common factor from all 3 of those numbers here. So, we're going to go ahead and move on in our checklist to counting the number of terms. It looks like I've got 2 plus signs in the mix, so that means I'm going to have 1, 2, 3 terms. This is a trinomial. And the first thing to always check to see is if this is going to match up to your perfect square trinomial formulas. And I am noticing that here in this example, I do have a plus sign right there. So if this does match up to one of those formulas, I know that this is going to match up to u squared plus 2uv plus v squared. Okay? And in the last video, whenever we were trying to match up to our forms here, we said that we should look out for some flags that are an indicator that one of these formulas is going to apply. And in terms of flags, I think we could definitely notice here that we do have some hints or some flags here, right? We see numbers like 9 and like 16. These are perfect square numbers. We're seeing these exponents of 2 in the place where u squared and v squared would sit, okay? These are also good flags that, that a formula can apply here, okay? So if you suspect that a formula applies, then let's brainstorm a little bit on what's playing the role of u and what's playing the role of v, okay? And then we'll go ahead and write our result over here because, again, if this applies, then this is going to factor in a very easy way. Whatever u is plus whatever v is, all squared, okay? So let's just identify what's playing the role of u and what's playing the role of v, right? So apparently, if I have u here in the very front, okay, u is the thing that's being squared in my very first term. So if you look at your first term, we've got a 9x squared. So what would we have to square in order to get u squared there, or a 9x squared? Well, to get 9, I would have to square a 3, and to get x squared, I would have to square an x. So that means that playing the role of u for us is just simply going to be the monomial 3x. Now, if you move on to your v, it's the same question. I want to figure out what I would square to end up with what I've got right here, this 16y squared. Well, of course, what you square to get 16, of course, is 4. And what you square to get y squared, of course, is y. So the monomial 4y must be what I square to end up with this 16y squared here. And again, the only remaining thing that you would need to check here, now that you've pointed out what you suspect would be u and v, is you just need to check this middle term, right? So with these definitions of u and v right here, is it the case that if you take u times your u times your, 2 times your u times your v, do you get 24xy? Well, yes, we do, because 2 times 3 times 4 is going to give us 24, and then the x and the y in those monomials, 3x and 4y, that's going to give us the xy at the end of that. So this is a perfect match for the perfect square trinomial formula, and we're going to go ahead and apply the formula. All we just need to say here is whatever's playing the role of u, which for us was 3x, plus whatever's playing the role of v, which is for us 4y. we're going to square that, and that's going to be our final result here in this problem. Okay, so again, whenever you guys have a trinomial, always look for that GCF first. And if you notice that there is not a GCF, you move on your list, maybe check to see if it's going to fit one of those perfect square trinomial formulas. If it does, you just have to identify what's playing the role of u and v, and then see if you match up to that middle term. And if you do, you can apply the formula, and that's a complete problem. Okay? So that is pretty good there. I'm going to go ahead and move on to maybe an example of a trinomial that does not fit one of these nice formulas here, okay? So again, I said we're going to jump around. Let's go ahead and take a look at number 17 up here, okay? So again, start at the top of your checklist. Number 1, always check to see if you've got a GCF. I don't believe we're going to have one here because we've got numbers like 2 and -5 and -12. These are numbers that don't really have any common factors, so no GCF. We're going to move on into our list. We see we have 3 terms here, so this is a trinomial. And the trouble with trying to pin this to one of your perfect square trinomial formulas, that is a minus, so we might suspect that this is going to be u squared minus 2uv plus v squared. But some flags here that this is not going to apply are the fact that we don't have very many perfect square numbers in this problem, okay? -12, that's not a perfect square number. 2, that's not a perfect square number, okay? So, unfortunately, trying to find u and v here are going to be a little bit of a struggle for us. So we are not going to apply our formula for that. We're going to apply this other method that I'm going to show you right now. This is the method of unfoiling, okay? And so, by way of introducing this, I want to go ahead and take a look at an example of maybe a FOIL problem that you would have seen in an earlier algebra class. So I'm just going to go ahead and make up a quick example here, and then I'm going to let that be the thing that helps me explain this process, right? So let me just make one up. How about, like, say, x plus 1 times 2x plus 3, okay? Let's say that that was a foiling problem that we were given, okay? Well, don't forget how to foil, right? So F-O-I-L, F-O-I-L, all right? That stands for first, outer, inner, last. So if we were doing the F in our FOIL, that is to take the first term times the first term, and that's F in FOIL. So in this example that I just made up, that would be x times 2x. That would make 2x squared, okay? The outer would be to take our outer 2 terms and multiply those together. So that would be 3 times x, which is 3x. So I'll say plus 3x there. Our inner terms, that would be 1 times 2x. That would simply be plus 2x for my inners. And then for my last terms, I'm going to have 1 times 3 as my last, okay? And that is going to give us positive 3 there, so I'll just tack on a plus 3. What I want you to notice is that about 99% of the time, your outer and your inner are actually going to be like terms that you can combine, and here that is definitely the case, okay? We can go ahead and combine those up, and that would give us this trinomial 2x squared plus 5x plus 3, okay? And so that is going to be your result here, all right? But what I want you to notice is that we are about to work backwards from this process, okay? If you work in this direction, going from the 2 binomials you're multiplying out to the trinomial, that is something called expanding. Because you're actually taking the 2 binomials you had, you're expanding this into a single trinomial. If you work in the opposite direction, which is what we're about to do, we're about to take this trinomial and we're about to write it into what we would have to multiply in order to get this trinomial. That is called factoring. So that is working in the opposite direction. And what I want us to do whenever we factor a trinomial is I don't want us to lose track of what is our f, what is our o plus I, and what is our L. Okay, so let's demonstrate that process by coming back down here to number 17. Okay, so by what we just discussed, the 2x squared, that would be the f in our FOIL. Okay, the -12, that's the number that comes last, so that's going to be the L in the FOIL. And then this -5x here is going to be what we get whenever we combine the outer plus the inner. Okay, so if you are trying to factor this, then keep in mind that factors into the product of 2 binomials we said before. So I'm just going to go ahead and start off by writing my 2 sets of parentheses here, okay? And what I typically try to do whenever I'm doing these problems is I'm either going to start off with the F or I'm going to start off with the L, depending on which one is easier to break up. Okay, so here I think that's going to actually be the F because what I've got is a 2x squared. And I want to break that up in terms of what is going to sit in my first seats in both of these binomials here. Well, the reason I might start off with the 2x squared is because there's really not a lot of ways you could break up a 2. There's really only 2 and 1. So I'm going to go ahead and break up my 2x squared there as 2x times x. Okay, and that's going to be the F in FOIL. What I'm going to do next is I'm going to go ahead and move on to looking at my L in FOIL, and here that is a negative 12. And the reason I'm looking at that is because I now need to figure out what's going to be sitting in these seats, and that's my last times my last, right? So if I need to make a negative 12, what I need to do is I need to brainstorm on all the different ways that I can make a negative 12 by multiplying two numbers. I could use negative 1 times 12, or I could also use positive 1 times negative 12. And I just want to kind of investigate all the different combinations. So I'm going to go ahead and complete this list. Maybe say negative 2 times 6. I've also got positive 2 times negative 6. I'm going to have something like negative 3 times positive 4 and positive 3 times negative 4. Okay? So these are all the different cases here. And I'm going to go ahead and erase some of my writing in that earlier example just so that we can focus on what we're doing here. Okay? What I'm trying to do now is I'm trying to figure out which one of these combinations is going to be the one that I can plug in here. Okay? I need to figure out which one of these this is. So that's why I'm going to call this method guess and check, because you are going to guess at which one of these pairs you need to plug into your spaces here that's going to be the correct one. How do you determine which one is the correct one? Well, you are going to let the only thing we haven't looked at so far be your guide. Okay, so we're going to look at that middle term, that negative 5x, and we're going to think about the outer and the inner and what it would be if you plugged in certain things in these spaces, right? So let's just say, for example, that you suspected that maybe it's this first combination that's going to work here. Maybe it was going to be that negative 1 and positive 12, okay? So you might go through an experiment here, and I'm going to do this in a different color because it's going to be a temporary thing that I write in. Maybe you suspect that this is going to be a negative 1 here and a positive 12 here, okay? Well, you are going to let the outer and the inner be your guide in terms of figuring out if that's correct or not. Because if you do the outers, that's going to be 2x times 12, and that's going to be 24, which is a whopping big number compared to what we actually want to be, which is negative 5. And if you do the inners, that's going to be negative 1. So that would be a 24x minus 1x. That's not going to give you negative 5x. That gives you 23x. So we know we don't want that, okay? We know we do not want this first little combination here. So I'm going to scratch that out. Maybe say you move on to that second combination. Well, hopefully you can reason with me here that that's just going to end up being the same thing. If I just had positive 1 and negative 12, again, I'm going to try to multiply these out, my outer and my inner, and combine them to get a negative 5. I don't think that that's going to happen with a number as big as 12 in the mix, okay? And so you move on. You maybe suspect that maybe it's negative 2 and positive 6. Okay, well, if you do the outer and the inner on that, that would be the outer. That would be 2x times 6. It's going to give you 12x. And then do your inners. That's going to be negative 2 times x, or negative 2x. And then if you actually combine that outer and inner, you're not going to get negative 5x. You're going to get 10x. Okay? And so I know that this process kind of seems like a little daunting, right? Like, it's not one of those things that has a definite step 1, a definite step 2. I am kind of taking you through a method that I'm kind of guiding you through here, but it is going to be this method of just kind of checking which numbers work and which don't work. If you go through this list, I will share with you that the only ones that are going to work here are going to be the one where you have a 3 and a 4, some combination, okay? So I'm just going to go ahead and put a 3 and a 4 there. Now, the next thing you want to think about here is the fact that I need to multiply to make something negative and then add to make something negative as well, okay? And so playing with the combinations here, what you might find here is if you do your outer, that's going to be 2x times 4. That would make 8x. And then if you do your inner, that's going to be 3 times x, or 3x. Keep in mind, I want to combine these so that I get a negative 5. And so I'm going to have that if I have a negative 8 and a positive 3. And so how is that going to work out with my numbers here? Well, I can have my 3 and my 4 as long as I make a negative 8. So I might say I'm going to go ahead and do a negative 4 here and a positive 3, okay? And that is going to be the factorization that we want to go with here, okay? Now, again, let's go ahead and discuss this because this is going to be a point of contention with a lot of students. I just took you through that method. It seems like it's a long, complicated process, but I promise you, if this is something you're able to practice from example to example and you get that process down, this is something that is going to eventually take you a cumulative total of probably about 20 seconds to do, okay? And you can contrast that with the method that I'll show you in the other video I'm putting in our Schoology folder, which is going to be very algebra heavy and very step heavy, and something that's probably going to take you a total of probably about 2 minutes from example to example. So if you can get to this process, again, this is called the guess and check method. This is going to start to become something that's very quick for you to do, and it's just going to be something that's going to help you move through this stuff with some relative speed. okay? So I want to demonstrate that process again by looking at number 18 here, okay? So we have this polynomial 6x squared minus x minus 1. Go through your checklist. I'll give away the punchline here. You don't have a GCF. This is not going to match up to any of your perfect square trinomial formulas, and so we are going to go ahead and skip to trying to unfoil this. So I'm going to go ahead and write two binomials, and remember how that process went, right? This would be our f in FOIL, this would be our L in FOIL, and the middle term is what we get when I combine the outer plus my inner, okay? Now, I'm probably going to pick the easier one of these three to work with first, and I think that that is simply going to be the L part, because that is going to be a -1, and the reason I start with that and say that it's the easiest is because there's just not a lot of ways that you could break up a -1. Really, your only choice is going to be +1 times -1. And I am going to go ahead and put those in the last spaces because, again, that's my L in FOIL. That is my last term times my last term to get a -1. My only thing now is I need to go ahead and figure out what's going to go ahead and sit in these remaining spaces, right? What am I going to put here and here? Well, in order to figure that out, let's go ahead and take a look at your F in FOIL. Now, that is going to be a 6x squared. And if you think about a 6, there's a bunch of different ways that you can break up a 6, right? There is 1 and 6. There's also -1 times -6. And there's also 2 and 3. So some combination of these pairs of numbers, we need to kind of guess and check which one of these two combinations are really going to be the ones that work for us here, okay? And so let's investigate that. Maybe let's say you suspect that it's going to be this first combination, maybe some combination of 1 and 6. So you say, I got a 6x squared, maybe you do like a 1x times a 6x, okay? Maybe that's the one that's going to work for me here. Well, how do you figure out if that's correct? You look at that middle term. You look at your outer and your inner, and keep in mind what you want to add to. This is a coefficient here of -1 that you want to add to, okay? So if you're guessing that 1 and 6 might be your combination, let's check it. Let's test it out, okay? We're going to do that by doing your outer, which would be x times -1. That's -x. And then your inner. That's 1 times 6. That'll give you a +6x, and that, when you add them, those are going to actually give you +5x, and that's not what we want. We wanted a -1x, okay? And I hope that you can kind of reason why, if you were to flip that around and maybe call that 6x and this x, it would really be the same dilemma. We would not add up to that -1 that we wanted. So, okay, maybe you scratch that out. That's not the combination we want. Maybe we want a combination of 2 and 3. So let's check that, right? Maybe let's say you suspected that this would be 2x and this would be 3x, okay? Well, if we did that, let's check our outer and inner and see if that gives us what we want. Our outer here would be 2x times -1. That's -2x. And our inner, that would be 1 times 3x. That gives us a +3x. And if we add those up together, that would be -2 plus 3. That actually gives us a +x. So we're close here, but we're not quite accurate because, remember, we want a -x. So how can we fix this? Well, what if we were to just go ahead and swap the 2x and the 3x? Maybe go ahead and call this 3x and call this 2x. Then do we have what we want? Well, let's find out. We're going to go ahead and investigate here by multiplying our outers together. That's -1 times 3x. That's -3x. Multiply your inners. That's 1 times 2x. That'll be a +2x. And if you can combine those, there you go. There's your -x, and there's the combination that we wanted all along. And so, now that you have your two binomials, you are just finished with this problem now, and you can box that, okay? So, in my opinion, if you can get used to that method, this guess and check method, as long as you're doing that checking part, this can be a method that if you get used to it, it's going to take you no time at all to do, and it's going to be so much easier than the method that I'll demonstrate in the other mini video that'll come after this one, okay? So that's just a quick tutorial on how to factor trinomials, and again, there's lots of other resources online, and you can always feel free to come up and ask me questions about how that process works, and we can sit down and refresh you on that, okay? But I'm going to go ahead and move on to some other examples here, show you a really quick factoring by grouping example, right? So if you're moving on in your checklist here, which we'll go ahead and pull up real quick just so we can look at it, all right? So we're going to go ahead and leave the realm of 3-term polynomials, and let's say you have an example with 4 terms in it. Well, that is going to be this process of factoring by grouping, okay? And so obviously, according to the name, that is going to mean that we're going to be grouping some things here. So let's go ahead and investigate how that's going to work here by taking a look at this example number 27, okay? We have a 4-term polynomial. Check for that GCF first, always. Go through your checklist. Not going to have a GCF here. It's got 4 terms, and so we're going to factor this by grouping. Okay, so what does that mean? Well, in our 4 terms, I'm going to go ahead and put the first 2 terms in a group together. I'm going to put the second two terms in a group together, and we're going to go ahead and look for a GCF in both of these groups, a greatest common factor, okay? And when we do that, I think it's going to be pretty easy to find. This is exactly what we did in the previous video. If we take a look at these two terms here in the first group, x to the third and x to the second, I think they can both give up 2 copies of that x that they have. And so that'll be the GCF in that first group. So this will be x squared times the leftovers. And if you do those divisions there, you're going to be left with x minus 1 left over. Okay? So that's the first group. We're going to hold on to that. Now we're going to move our attention to the second group. And the thing about factoring by grouping is that you want your leftovers to match. I'm actually going to make a note of that over here, right? When you factor out something in both groups, you want your leftovers to match. So I'll say that here. Leftovers must match. So if we ended up with some leftovers in that first group of x minus 1, we want to end up with some leftovers in the second group that look identical to that. So x minus 1 here yet again. All right, so the question now becomes, what would I factor out of that second group to be left over with an x minus 1? Well, I think the answer is pretty obvious here. They both have a factor of 2 in common. So if we were to factor that out, we would just simply say plus 2, and then our leftovers would look identical. And the reason that we want our leftovers to look identical is because I have my first group plus my second group, and the way you could look at this is they both have that common binomial factor of x minus 1. So that means I could go ahead and factor it out, x minus 1 times the leftovers, which would be your x squared plus 2. Okay, Mr. T, where did you get that x squared plus 2 from? I just got it from what was left over after I factored out the x minus 1s there. And so this would be a complete factorization of that 4-term polynomial there. Pretty darn easy to do. Again, just group together the first 2 terms, look for a GCF. Group together the second 2 terms, look for a GCF. You want those leftovers to identically match so that you can factor those leftovers out in a third step and get to your final answer there. The only other type of example that I want to talk about are maybe some of the ones that show up near the end of this set of notes, which are examples where we want to really make sure that we are factoring completely, okay? So this is why it says on your checklist that you may have to go through this process more than once in order to make sure that you factored completely. So just because you do one step of factoring doesn't mean you might be finished. What I want you to always do is look at the leftovers that you're done with and determine if you can continue to factor, okay? Some of these might be a little bit more challenging than others, but I just want to go ahead and take you through some examples here. So let's maybe take you through, let's say, number 33. Remember that all these examples will be done in the content library for you, ready to go. So if you need to look at any of these, you always have access to that in OneNote, okay? But if I take a look here, again, we're going to start at the top of our checklist. We're always going to do number 1, look for that GCF. I've got 3 terms here, and if I look closely, it looks like they all have a single copy of x that we can factor out of each one of these. So that's why I'm going to go ahead and write this as, remember how we said to write this, it goes GCF times the leftovers, okay? And so if I factor out that copy of x, we'll just go ahead and do these divisions here. So x cubed divided by x makes x squared, plus x squared divided by x makes x, and then minus 6x divided by x, that's going to give you 6, okay? So we just factored out that GCF, but we may not be finished because what I always want you to do is take a look at what you have left over here and determine if you can keep going, okay? Well, that is a trinomial, okay? It's not going to have a GCF because we already pulled one out, but since that's a trinomial, then we're going to go to the 3-term space on your factoring checklist, and we're going to determine if this is going to be one of those perfect square trinomials or if this is going to be one of those ones where we're going to have to unfoil, okay? And so if you try to match this up to one of your formulas, according to what we talked about before, I don't think this is going to work because we would have to match up a 6 to that v squared part in the formula, and 6 is not a perfect square number. And so what that's going to mean is that this is going to be a trinomial that we're going to try to have to unfoil, and we're going to do it by that guess and check method that we discussed a bit ago, okay? Remembering that this would be my f in FOIL, the 6, that would be my L in FOIL, and then this middle term would be what I get whenever I try to combine my O and my I, the outers plus the inners, okay? Well, I might go ahead and just start here with the f in FOIL because that, to me, seems like the easier one to start with. It's just x squared. So going in my first terms here are just simply going to be x and x, so that when I multiply my first times my first, I get x squared going on there, okay? So that's pretty easy to do. Next thing I might do is I might go ahead and look at my L part. That's going to be a -6. And so in my head, I need to kind of think about all the different ways that I can multiply 2 integers to make a -6. I could have any combination of 1 and 6, or maybe any combination of 2 and 3, much similar to the one that we talked about on the previous side of the page here. And keep in mind, the way that you determine which one you're going to go with here is you are going to take a look at what you have here in the middle. What does your outer plus your inner turn out to be? Well, it turns out that just turns out to be plus 1x, okay? So that's a 1 on the coefficient there. So that might lead me to believe that what we may want to try here is not the 1 and 6, because I think that's going to give us too big of numbers. Maybe let's go ahead and try the 2 and the 3, okay? Now, I need to multiply these to make something negative, but add them to make something positive, okay? So that's going to be a dead giveaway that the larger of these two numbers is going to have to be the negative one, or sorry, the positive one, I should say, and the smaller of the two is going to have to be the negative one. And if you don't believe me, again, that's why this is called guess and check. You can check that. You can check your outers here. That is going to make positive 3x. Check your inners. That's going to make negative 2x. And then positive 3 minus 2, that's going to mean the x that we have there in the middle, and we know we got this exactly right. So again, guess and check method is going to go very, very quickly for you if it's something that you can feel like you can get used to, okay? So this would be an example of one where the factoring doesn't stop at doing one step of factoring. We took out the GCF, but we weren't quite finished yet. We had to look at those leftovers and determine if we could keep going in the checklist, okay? And that's something that I always want you to do. The very last example that I want to try to do in this video is one that has some of these binomials in parentheses. Okay, so maybe let's take a look at number 35, and then we'll finish the video up. All right? So again, don't forget how we're going to look at this. We have two terms in this whole expression. They're separated by this big plus sign right here. So I've got this first term plus this second term. And what I want to do is I want to look at both terms and identify if they have any common factors. And it looks like the factors that these two terms have are a bunch of binomial factors. So if I look closely, I will identify here that it looks like I have an x plus 1 copy in that first group. And then in the second group, I have 2 copies of x plus 1. Okay? Well, if I'm going to try to factor this, then I'm going to factor out what they have in common. And so I'm going to go ahead and factor out simply one single copy of x plus 1 in both of these groups. Okay, so if I go ahead and continue here, remember how we always write this, it goes GCF, which is x plus 1, times the leftovers. Well, what's left over if I factor out a single copy of that binomial, that x plus 1? Well, in that first group, check out what happens here, because I'm going to have the x plus 1 in the top cancel out with x plus 1 in the bottom, and it just simply leaves me with this 2 times x minus 2. So I'm going to go ahead and write that here, 2 times x minus 2. And then I got my big plus sign in the middle, and then what's left over after I factor out a single copy of x minus 1 from that second group? Well, keep in mind, that second group had 2 copies of x plus 1, and if I take 1 away, then that means instead of having 2, I'm going to only have 1 copy left, and so I'm going to end up here with 3 times the remaining copy of x plus 1 that I was left over with there. So I'm going to say that. I'm going to say 3 times x plus 1, and that is what my leftovers are going to look like, okay? Now, we do need to continue this, and it looks like here, if you look at what we have left over, that doesn't look like something that's going to continue to factor, but instead it looks like something that we can go ahead and expand, right? So we can go ahead and take these values of 2 and 3, and we can use some distributive properties to go ahead and distribute that to both terms on the inside, and then maybe combine some like terms, and then we'll complete the problem that way. So here goes our GCF of x plus 1 in the very front. That's something that is still out front, doesn't go anywhere. But we're going to do the distributive property here in this other set of parentheses. So real quick, that's going to give us 2x minus 4 plus 3x plus 3 if we distribute in, okay? And now, of course, we have some like terms to go ahead and combine here. So we're going to go ahead and say that I've got some variable terms to combine. Let's say we got a 2x plus a 3x. It's going to give us a 5x, right? So here goes the x plus 1 in the beginning. Again, that's still in the front, doesn't go anywhere. But in our leftovers, we're going to combine our x terms here. We're going to get 5x when we combine the 2x plus the 3x. And then when we combine our constants there, we've got a negative 4 plus a 3. And that's going to give us a negative 1. So we're going to say minus 1, and that is going to complete the problem there. 2 linear factors for that polynomial, okay? I know we have a ton of other examples here in this set of notes, and I don't quite have enough time here in this video to go over absolutely every single one of them, but feel free again to check out that content library for the completed version of today's notes. I hope this video has been of some help to you. Watch out for that other video that's going to demonstrate that other method for solving or how to factor a trinomial. But that's all I got for this one. Thank you very much for your attention, and I'll speak to you in the next one.